Hello friends, welcome to Abundant Academy. In the last lecture, we have completed the discussion on the tangential and the normal velocities and acceleration. So in this particular lecture, we will discuss about the problems on that topic. So let's start our discussion. What is given in the question? Velocity of a point moving in a plane curve varies as the radius of curvature. So that the direction of motion revolves with a constant angular velocity. Okay, so let us solve this. So we have the velocity is proportional to the radius of curvature. So we can write v is equal to k rho where k is equal to constant. Okay, so we can write rho as we are having the radius of curvature as ds upon d psi. Okay, suppose there is a point p in the curve and the tangent at that point makes an angle of psi, and this path traversed by this point is s. So we have the radius of curvature rho is equal to ds upon d psi. And this is our radius of curvature rho. Okay, so we have k into rho. Rho is ds upon d psi. So let us divide by dt at the numerator and denominator. So we have v is equal to k into ds upon dt upon d psi upon dt. We can take d psi upon dt in the LHS portion. So v into d psi upon dt is equal to k into ds upon dt. We can write as v. This is v. So this gets cancelled. So we have d psi upon sorry. We have d psi upon dt is equal to k. This means psi is equal to constant. Therefore, direction, so that the direction of motion revolves with direction of motion revolves with constant angular velocity. Okay, let us discuss question number 2. What we are having is that the cycloid s is equal to 4a sine psi with a uniform speed. The speed is uniform, speed is equal to uniform. This means v barabar constant. Okay, find the acceleration at any point. So v is equal to constant. This means dv upon dt is equal to 0. This means v is equal to v, we can write as v is equal to ds upon dt. So d upon dt of v is ds upon dt. ds upon dt is equal to 0. This means d2s upon dt square is equal to 0. This is equation 1. So we have this is equation 1 and we just take this as equation 2. So we have acceleration is equal to d2s upon dt square ka whole square plus v square upon rho ka whole square ka under root. So ds upon dt is 0, so this means this gets cancelled. So we have v square upon rho is the acceleration. Okay, so we can write rho is equal to ds upon dt. We can write it. Find the acceleration of any point. So we have um, rho is equal to ds upon d psi. This is equal to d upon d psi of s is equal to 4a sin psi. So we can write this as 4a cos psi. Rho is equal to. So we have acceleration as um, v square upon rho. Rho की value 4a cos of psi. This we can write as v square upon 4a 1 minus sin square psi. Okay, from here we have sin of psi is equal to s upon 4a. So we have acceleration is equal to v square upon 4a into 1 minus sin square psi s square upon 16a square. This we can write as acceleration is equal to v square upon 4a into 4a upon 16a square minus s square. This gets cancelled. So acceleration is equal to v square upon 16a square minus s square under root. This is our acceleration. This is the acceleration of point. Okay, acceleration of point on cycloid. Let us discuss question number 3. Prove that the acceleration of a point moving in a curve with uniform speed. So speed is uniform. The speed is equal to uniform. That is v is equal to constant. Okay. So we have v is equal to ds upon dt equal to constant. Let us differentiate it again. This means d2s upon dt square is equal to 0. This is equation 1. So we have the acceleration as d2 square d2s upon dt square whole square plus v square upon rho का whole square. V square upon rho का whole square under rho. So this gets vanished because it is 0. This is equal to v square upon rho. So acceleration is equal to, we can write this as, we can multiply rho in the numerator and multiply rho in the denominator. The rho is equal to v square upon rho square. This we can write as rho into v upon rho का whole square. So we have acceleration is equal to rho into v is equal to ds upon dt upon rho is equal to ds upon d psi whole square. This we can write as rho into d psi upon dt का answer. This is the acceleration. Prove that acceleration of a point moving in the curve. So the acceleration of point is rho d psi upon dt का whole square. Okay. Let us discuss question number 4. So what is given in the question? If the tangential and the normal acceleration of a particle describing a plane curve be constant throughout, prove that the radius of curvature at any point. Okay. So what is given in the question? We have the acceleration as a tangential square plus a normal square under root. So we have at is equal to d2s upon dt square is equal to dv upon dt is equal to constant. Let us consider this constant as lambda. Okay. So we have here and this implies that v is equal to lambda into t plus c on integration. Let us consider this as equation 1 and we have normal acceleration v square upon rho is equal to mu. This is also constant. We have the tangential and normal acceleration of particle describing a plane curve being constant throughout. This is also constant. So from here we have rho is equal to v square upon mu. So let us place the value of v here. Rho is equal to lambda t plus c whole square upon mu. This we can write as lambda t plus c upon root under mu whole square. So we have rho is equal to lambda upon root under mu t plus c upon root under mu whole square. So this is equal to at plus b ka whole square where a is equal to lambda upon root under mu and b is equal to c upon root under mu. Okay, so this is our radius of curvature. Radius of curvature. Okay. Now let us discuss question number 5. What is given in the question? The particle describes a curve for which s and psi vanish simultaneously. Vanish simultaneously with uniform speed. The speed is uniform. Therefore v बराबर constant. So we have dv upon dt is equal to 0. This means d2s upon dt square is equal to 0. This is equation 1. So we have acceleration is equal to d2s upon dt whole square plus dv upon, normal acceleration is v square upon rho. So we have v square upon rho का whole square का under. So this gets vanished. So we have v square upon rho. So we are having the acceleration as acceleration given in the question is v square c upon s square plus c square. Okay, so v square gets cancelled. So we have rho is equal to ds upon d psi. This means 1 upon rho is equal to d psi upon ds. So we have here 1 upon rho. So this is d psi upon ds is equal to c into 1 upon s square plus c square. So from here we have c into ds upon s square plus c square is equal to d psi. Let us integrate this. So we have c into 1 by c tan inverse s upon c is equal to psi plus a. This we are having is tan inverse s upon c equal to psi plus a. So what is given in the question is that s and psi vanish simultaneously with uniform speed. So when That is when S is equal to 0, psi is equal to 0. So we have tan inverse 0 is 0 is equal to psi is equal to 0 plus A. This means A is equal to 0. So from here we have tan inverse S upon C is equal to psi. So from here we have S upon C is equal to tan of psi. S is equal to C tan psi. This is the intrinsic equation of curve. Okay, and in fact what we have studied in statics is that this is the equation of common catenary. Okay, so S is equal to C tan psi is equation of common catenary. This we have discussed in statics lecture series. Okay, so we will discuss further questions in next particular lecture. Thank you.